Good. So we're recording. We're doing a recording on section 5.6 notes, example 7. And here we have a ladder problem. So you got a ladder that's on the ground and rests on a vertical wall. So we should draw a picture. And remember, little thing here says read the problem carefully, draw diagrams, and also you got to know what's changing, what remains constant. So we're going to talk about those steps right now. So here is the wall. This is a wall. Here is a ladder. There's a ladder. And guess what? This is a right triangle, right? And how long is the ladder? 10 feet. The ladder is 10 feet. Great. And here's the ground, by the way. The ground's right here. So you want to be able to visualize this. Now, I'm going to call the ground X. I'm going to call the wall Y. Y is going to be the distance that the top of the ladder is from the ground. And X is going to be the horizontal distance the foot of the ladder is from the wall, from the base of the wall. Okay. Now, they say the bottom end is drawn away from the wall at a constant rate of 2 feet per second as the top slides down the wall. So basically what's happening is that this is sliding down like this, and that's going this direction. So X and Y are changing, right? But the length of the ladder is not changing. So that's what's being asked of us in this first step. Read the problem carefully. What's changing? The height of the ladder off the ground is changing. The horizontal distance, the foot of the ladder from the base of the wall is changing. But the ladder itself is not one of those sliding ladder. I mean, yes, sliding down a wall, but it's not one of those ladders that you can extend out. It's just a static length. It's 10. It's staying the same. And then you have to do two diagrams. I obviously did one where I labeled with letters, but I haven't used really quite numerical values, except for ones that don't change, like 10 here. But the second one is called a snapshot moment. What's meant by that? Well, let's look at part A. Part A is asking us how fast is the top of the ladder sliding down the wall when the bottom ladder is 6 feet from the wall. So this is my second diagram. I'm going to do a second diagram. I'm going to call it the snapshot. The snapshot is this. I draw another right triangle. Of course, this is 10, right? The ladder is 10 feet long. And the top of the ladder, when the bottom of the ladder is 6 feet from the base of the wall. So when this is 6, anyone know what this is going to be? So 6 is the horizontal length, right? Because that's, what they said that, right? When the bottom ladder is 6 feet from the base of the wall. So how high is the top of the ladder from the ground? Use Pythagorean theorem. How long?
Isn't it 8?
Just 8, right? And by the way, they try to keep the math simple here. Yeah, just 8, right? So that's the snapshot. How does that help us? You will see. Okay. So now let's figure out what's going on here. So now the third step is I feel really when you're really kind of getting down to actually the fourth step, getting out to the nitty gritty, but identify what you want to find. Well, we want to find how fast the top ladder is moving. So I want to find dy over dt. That I don't know. Now 2 feet per second, what do you think that represents in terms of a derivative? What do you think 2 feet per second would represent? Remember, look at x and how x changes with time. So it's dx dt, just so you know. It's dx dt. So now let's actually come up with an equation. What equation can I use that would relate? This is why it's called related rates, by the way. You're relating rates. You're relating variable. Equations are relationships, right? What relationship can I establish with x, y, and 10 here? What equation can I make with that? Anyone can share.
Could you do Pythag?
Perfect. X squared plus y squared equals 10 squared. 100% correct. Good. So there's a lot of geometry involved that's involved in this stuff. And of course, x squared plus y squared equals 100. Okay, great. Now, this is so that's step 4. So we've done step 3 pretty much. In 1 and 2. We've done step 4 now. Now step 5 is a big deal. We have to take the derivative. That's not hard. It's just 2x, but you do with respect to t, mind you. Two x times dx dt. Oh, it's y squared, yikes, sorry. Plus 2y times dy dt equals 0. Because derivative of 100 is 0, right? So what is this really assessing? This is assessing implicit differentiation, right? Remember, I think it's like section 4.2, I can't remember exactly. But remember we did this like right near the end of the fall semester around December or so. This is an application of implicit differentiation because you're taking a derivative with respect to a variable that's not the variable you see there. You're taking a derivative with respect to t, but you got x squared and y squared. So you got to put that dx over dt or dy over dt bit. Now we do substitution. See, here's the thing. This is where the snapshot comes into play. The snapshot comes into play because x is 6 here and y is 8 here, right? At that moment, you want that, because here's the thing. Well, you could do it for yourself if you want. You take a ladder and slide down your wall of where you live. You could do that if you want. You're going to see that ultimately it's going to start sliding faster because of gravity, right? I mean, there's a little bit of physics going on here, but it's it's not going to slide at a constant rate. It's going to slide a little bit, then goes down fast. So anyway, we need that snapshot. So you have 2 times 6, and dx dt. I do know it's 2 because you told that. And by the way, dx dt is going to be positive because x is increasing in length, right, as time passes, right? Plus 2 times 8, we want to solve for dy dt, equals 0. Now your task is to solve for dy over dt. So now we're almost at the last step. Solve for what you want. You substitute it, solve for what you want. So we do that. I'm going to need some space here, so let me kind of erase stuff up top. We know this. Okay, so work it out. You get 24 plus 16. I'll call it dy dt equals 0. Move things around. Dy dt will equal negative 3 over 2. And that's going to be feet per second. Now, the answer for part A was negative. Why does that make sense? Why should it be negative, not positive for dy dt?
Isn't y getting smaller because it's moving down?
Yeah, exactly. Y is losing value. So you always have to be mindful about that too. That's why people sometimes don't like these problems because they don't like to think. No, just kidding. They just no. It's higher critical thinking, which sometimes a lot of people don't have enough exposure to. You really got to think critically here. The College Board, interestingly, they what's the right word to use? It's kind of a forgotten. No, I would say forgotten, but they don't assess it too much. Like sometimes they throw us into the free response. It actually hasn't been covered. It was, I think, last year when they went online for the AP exam, but prior to that, like I think there was like 8 or 9 years in a row, they didn't do any related race in the free response, but they do it in multiple choice a handful of times. So you do have to be mindful about that, that they like this problem still. And they feel maybe it's easier to use multiple choice, I don't know. Maybe they want to do other stuff in free response. But it is higher critical thinking, so you do have to be mindful about the sign changes. And yeah, if you're losing value, that, yeah, it would be negative. Okay, let's do a bit more. So do BCs. Now you guys kind of get the idea. B and C will go by pretty fast, and I'll have you guys try one on your own while I check on the other group. Okay, area. Well, you guys should know area. What's the area of a triangle? One half times base times height. Okay, good. Right. I think you guys need it. Maybe just guys being silent. That's x, y, and 10, right? Again, I have to redraw a diagram. Well, what's my base here? My base here is x. My height is y. Okay. And I already know, now I know what dy over dt is. dy over dt is negative 3 over 2. And I know dx over dt is 2, right? Positive 2, by the way. So yeah, let's do our derivative. I already got the equation now. I already got a diagram that I did earlier. Let's just get to it. Take derivative both sides, because you want to know how the area is changing with time, right? That's what Part B is asking us to do. So yeah, you got dA over dt, awesome, equals 1/2. Now you got to do a product rule here. See, this is why I love these kind of processes. Really kind of forcing to look back at all the old stuff, right? So you got to do derivative x first, which is 1. But you got to say dx dt times y plus x times 1 times dy dt. Okay. 1/2 times bracket dx dt I know is 2. And y, of course, remember this is 8 and 6. Because remember, we're all doing it at this moment here. So still at the same moment when the ladder is 6, the base of the ladder is 6 feet from the wall of the building, or the bottom of the ladder is 6 feet from the wall, base of the wall. Because they said at that moment, right? So 2 times 8 plus x, 6 times negative 3/2. Remember, dy dt is negative 3/2. Work it all out, and you should get 16 minus 9, I think. Yeah. So the area is changing by 7 over 2 or 3.5. And you got to use the right units. It's going to be squared feet per second. You got to state the units as well. Square feet per second, because it is area, right? Okay, that's part B. Any questions so far before I do part C? Nope. Okay. Again, I'm recording this, and I will have to share this recording with you guys. Lastly, part C. At what rate is the angle theta between the ladder and the ground changing at that moment? Okay, well, let me draw it one more time. That diagram. And theta is between the ladder and the ground. So this is theta right here, right? Here's x, here's y, and here's 10. And technically, you know, this is really 8 and 6 because we're looking at that moment, right? Well, what should I do? You could do a few things, actually. We need an equation that involves theta and the sides. I don't have an idea of what equation I can write here. What do you guys think I could do?
Could you use like tangent?
Sure. Use tangent. And of course, it'll be y over x. And then you do quotient rule. Or you could write like this and do product rule with the chain rule if you want. Or you could do this. Why not do sine theta? Y over 10. Because hypotenuse is static. Or why not do cosine theta? X over 10. Personally, I would do sine or cosine. Even though tangent seems tempting because we deal with that often when doing these kind of like trick situations. But sine or cosine might be easier because you don't have to do a quotient rule. So I'm going to be in favor of, let's just do sine. But you have some options. If you really want to get tricky and say, hey, let's do a secant, cotan, have at it. If we were doing it as a real class, I may give extra credit for that. But why? It's just more complicated. Let's keep it simple. We'll do sine theta, y over 10. Okay. Now let's do the derivative with respect to t. Okay, so that's what's that going to be? That's going to be cosine theta, right? But you got to say times d theta of dt. You got to say that. And that's what we're trying to find, right? We're trying to find d theta dt. I should probably mention that right from the get-go. What we're trying to find here, that. Okay. And what's this? Well, that's just 1/10, but times dy over dt, which we already solved for in part A. We already knew dy over dt in part A was -3/2, right? So yeah, let's do this. And that's 1/10. I was messy handwriting. My apologies. The cosine theta is 6/10. Yeah, so 6/10. D theta dt. Okay, 1/10, and dy over dt is -3/2. Boom, there we go. So that's -3/20, and that's 3/5, of course. So you got to multiply both sides by 5/3. You move it around. So it's -1/4. Now, anyone have an idea what the units would be for this? Because it's an angle. Radians. Remember, we don't do degrees at all in this class. Radians per second. And that does make sense because the ladder is sliding down, so that angle is getting smaller, right? So it should be losing value. You always want to kind of physically ask, does that make sense, what's happening here? By the way, they'll never design an AP style problem like this with 3 parts for just related rates. I would be shocked if the AP did that this year, or the College Board did that on the AP exam. Plus, they don't like having one question. If you miss part A, then you miss the rest of it. They kind of like to have each part kind of somewhat independent so that it's easy to grade. Obviously, if you got part A wrong, then you're going to miss part B and C. But it's just good practice, right? That's what's happening with that problem. So this is a quintessential related rates problem. It's like one of the most fundamental related rates problems. Any questions? Okay, so we got about 10 minutes before we have to sign. So here's what I'd like you guys to do. If you click on worksheet 15, you can find Schoologies for 5.6. Go and start with number 2. Because number 2 is very, very similar to what we just did. And then try number 1 after that. If you have time, maybe you could try number 3. I highly doubt you're going to be able to do all this in 10 minutes. I actually probably should not. I don't know if I have the answer key. I might have to create it. So we'll see here. Solution keys. Or I might have to do a little digging around. Yeah, but anyway, we could just check in really quickly. I want you guys to do it right now. Talk to each other. Hopefully everyone gets the same answer. That's a good thing. But I'm going to go check on D period. If they don't need much help, then I'll come back and I'll try to work out that problem to make sure we get the same answer. But try that right now. It's good practice. Obviously, there's still other related rates problems that are good to talk about, like cones are kind of very popular, like when you're putting water into a conical tank. The shadow one sometimes can sneak its way and it's a little tricky. Those are things I'll have to do as a video for you guys to watch. And Albert IO as well. So I have some work. I got to create content for you guys. It's my fault. I apologize. I haven't been able to do that. You guys deserve that. I will do my best to get that done this evening. By tomorrow, hopefully, I'm going to make that as a task for myself to upload, let you guys know. And then you guys can do more practice next week. We could talk about 5.5 cell linearization. And at that point, my hope is that we're around the middle of March and we start session 3. Then we can kind of, as we work our way towards spring break, we start focusing on the other topics. And maybe what I'll do with the B period, maybe I'll kind of switch things around the B period. Say, my hope is like we'll start like I think maybe I might do 8.3 or 6. I can't remember. But whatever I'm going to do with you guys when session 3 starts, I'm going to have B period joined there too. I think that's just going to make my life a lot easier because they could really go in any order. Doesn't matter. And then once I'm done with you guys are just doing straight up just AP review. The B period will also have to learn some of the topics. And by the way, I think May 4th is the right test for you guys to take, just so you know. If you want to do May 24th, that's fine. I would not do June 9th, unless if you really feel like you want to do it digital. Because May 4th and May 24th, those are those options will be paper in school. But I think you guys will be ready for May 4th. You have my word. Anyway, once you guys get to work, I'm gonna go check in the other class, and then I'll be right back in a few minutes. Hey guys, just check and see how it's going here. How long is the video?
38 minutes.
How many?
38 minutes.
Okay, so it's pretty long. Okay, so here's what I should have done, and I will do definitely. You know, this for me, upload future stuff, and maybe I'll give us an update. Probably would be a good idea for me to do this, and then for you guys to follow through. On Mondays, maybe start watching, or maybe over the weekend, start watching the video for the next topic. So that way you have it watch, and then that way the breakout room would just be more about you guys just doing practice. And how you break it up is totally up to you, but maybe at the very least watch the video, and maybe we'd do the worksheet together during our AP study groups on Wednesday mornings. And then after that, then you guys can maybe do the textbook problems and then the algebra, or maybe even front load and say, let's do watch it and the worksheet before the AP study group. Let's do the textbook problems together, which are a little bit deeper, and then do the Albert IO problems as an assessment after. But at the very least, I think, because I don't want you guys just to use time to watch videos, but because I was so slow at uploading this, I had to give you guys something. But I think that's what my vision is. Maybe I'll start putting all this stuff up. You guys can start watching videos early before the class starts. And I think what I will do is, if you guys want, I could definitely check in with you guys. Is there like, I don't know. I mean, I'm just trying to think. I mean, how's your guys' schedule? Are your Fridays busy, or or how are your Wednesday afternoons? Like, I'm just trying to think like if there's other days or times I could talk to you guys.
Well, other than like getting my COVID test Wednesday, like I'm pretty good Wednesday or Thursday or Friday.
Yeah, I think after the 12:15 meeting, or after the
Okay.
community lesson gathering, after that, or at 2 o'clock.
2 o'clock. Okay. I think I could make it. I'll poll you guys, and I'll poll the other people. There's still other people I think will join this. I think just again, everything's just so new, but I'm gonna make a stronger push to get more people to join this. Yeah, that could work for me too, I believe. So okay. Yeah, because I really feel like I want to talk to you more than just a few minutes. But it's just it's great. But I think what I'm going to do with my B period is that when they're done with session 2, whatever topic I'm going to cover with my A period, AP study groups, I'm going to have B period join that as well. So I'm going to kind of reverse the order. So that way I don't not meet with 3 groups at separate times, because that's just going to just make my head spin thinking about that. So that way I could just make this more manageable. So anyway, just keep doing what you're doing. We'll come back in a few minutes. I'll try to see if I can arrange a new time for us on Wednesdays to talk.
And then also one other thing, I know you're really busy, but if any way you could print out some of the notes packets and put them in a locker.
Yeah, actually, that's a great idea. So I do have them actually. They're in my car. I had to for my B period students that we met in person. I had to bring them with me to in case someone didn't print it. But no, I could totally do that. I'll probably what I'm doing is I don't plan on being back council next week. I'll probably prepare some here at home and then just throw in the copy machine at school. And then I'll just put them in the lockers by Monday afternoon. So if you want to pick up Monday, is that okay if you guys pick up Monday afternoon?
Yeah, that's
I'll let
awesome.
you guys know. Then you guys can pick it. And then you guys watch the video on Tuesday, and then you have all the stuff. I'll have the whole semester, even when we're in session 4. I did it for A and B periods in January, but I didn't do it for you guys because there was just so much photocopying. But yeah, I think I need to do that for you. I'll do that. Not a problem.
Yeah. Okay, thank you.
Good idea. All right. So I'll see you back in the main room in a couple minutes. Okay, I'm back. Oh, I should have stopped the recording.